thinking about the things that you might use every single day, what kinds of technologies do you think optical engineers have already designed? What kind of things might you see or use every day that would have been the work of optical engineers?
They could have designed light bulbs and flashlights.
Good. Light bulbs and flashlights. What else?
Headlights for a car.
Okay.
Like a bulb inside like the microwave and stuff.
Okay. All right. So we're naming a lot of things that involve light with bulbs, but light is used in other ways as well, right? So what about the tinting on your car windows? Would that have been designed by an optical engineer?
Yes.
Why?
Because like it could be lighter, but they turned it dark.
Okay, so there was a problem that involved people getting glare or too much light into the car. And so, right, so the tinting on car windows or on any windows, they even use it in office buildings as well, that is used to block some light. So it's a problem caused by light that they provided a solution for. Turn and tell a person next to you, what do you already know? What schema do you have about how light interacts with different materials?
Like they reflect off the mirrors.
Maybe sometimes it reflects off the windows.
Yeah, because like sometimes the shine.
Sometimes the light goes through the window.
One. So I heard some good vocabulary. I heard the word absorb. I heard the word reflect. I also heard some other things that meant the same thing. Some people said that the light would go into some objects or it would bounce off of some objects. So we're going to be seeing how our work today in lesson 2 is looking at materials, seeing how certain materials behave differently when light comes upon them. So the work you're going to be doing today is going to be looking at different materials, and you are each group is going to be in charge of testing 2 different materials. And I will go over with you the setup so that everyone's conducting a controlled experiment. Your variable will be the materials that you're going to be using specifically, but the way that you go about testing will be controlled. So this way when we compare our data, we can be sure that it's valid data. We're looking at materials that would fall into 1 of 3 or maybe 2 of 3 categories. We're looking at materials that can either let light go through it, so lets light pass through it, that light bounces off of it, or that light blocks it or stops it. Okay? I'm going to do the transparency with you. How would you describe this transparency?
Clear.
It's clear, okay?
Shiny.
It is, yep, it is shiny, yep. You can see through, it's smooth. Is it thick or thin? Thin. Is it sturdy or flexible? Flexible. So we need to take all of those characteristics into our thinking when we go to characterize what type of material this is and whether or not it's going to fit the problem that we're going to be trying to solve later. So if I shine a flashlight through this, let's predict. Think about what category would this fall into. Give me a thumb up for an answer of yes, thumb down for no. How many people think that light will pass through the transparency? How many people think that light will reflect off the transparency? That light will bounce off? How many people think that the transparency will block the light? Okay. Well, let's do goes through first. How many of you can see the light through the transparency? I'm trying not to shine it in anyone's face. All right, so we're all in agreement that light is going through it, right? Okay? All right. If we look at it this way, if now you're on the same side as the light source, how many people would say that it is reflecting light? Good. If you can see some of the light coming back at you and you're on the same side as the light source, it's being reflected. How many people would say that some of the light is being absorbed by the transparency? Or that it's being blocked, that the light got sucked in and got stopped? So what we would actually need, technically as actual scientists, what we would need would be a special tool called a light meter. And we would need to be able to measure how much light is coming out of here and how much light is on the other end. It is a common fact that anytime light interacts with a material, a certain amount of it does get absorbed, but certainly we can tell with the transparency that the majority, most of the light is going straight through it, right? Okay, and then a certain amount of it is being reflected. Okay, So I'm going to give you a bag and a sheet. I'm going to talk you through the investigation setup. Then it says, does any light hit the walls? Where and draw what you observe.
You put the mirror in front of the flashlight. So if you just stay still, and you put the mirror in front of the flashlight.
It's reflecting.
It reflects. For wall 1, you would want to put a little edge of black, color it. And wall 2, you would want to put a circle, light reflecting off of it. If you come over here, you can see.
You don't see any light. You see like a little bit shadow.
Black circle with white
You
around
see
it.
the shadow? Oh yeah. Yeah, but that's from this. From right there. Yeah, then how can you see that if the light, you don't see it? I think it is reflecting.
Because it leaves a shadow.
It leaves a shadow, but it still reflects. It's reflecting on the cardboard,
It reflects
and it
a lot.
goes through over here.
And then the tissue paper.
Goes through.
It goes through, and it leaves a little bit of a shadow.
Yeah, a little bit if you look at it.
Because look, if I can make a shadow, that means there's some light over there. But look, let's see if that light is from, so some of the light, see how you can still kind of see my shadow? Yeah, but some of it is definitely from the flashlight. So you would, anyone who tested the black paper, light goes through the material?
No.
No. Light bounces off the material? No. Light stops at the material? Yes. Anybody else do black paper? Brian, do you agree with Michael's data? Yes. So the black paper was successful at only stopping the light. Good. Black paper with holes. What's the variable between black paper and black paper with holes? The holes. So any difference we see in our data, we can blame it on the holes. All right. Light goes through the material. Deanna, would you say yes or no? Did the light go through the material? Yes. Did the light bounce off the material?
No.
Did the light stop at the material?
No.
The black paper didn't stop some of the light?
Okay.
Right. Serena, would you say that the Mylar, that light is going through the Mylar? Yes. Where would you put reflection? Does reflection go with light goes through the material, light bounces off the material, or light stops at the material? Good. So this is going to be called reflection. All right. What about absorption?
Light stops at the material.
Yeah, the light's getting absorbed or sucked into the material so it can't go anywhere past it. And so the last one must go where, Ariana? Transmission. Right. Good.
Transmission lets light go through a material. Transmission light goes through the material, and reflection is the light bounces off the material. And then
Absorption light stops the material.
All right. So I had you include examples with your definitions because obviously we're going to be going back to these materials again in lessons 3 and 4, and you want to remember, well, what happened when I used that material? How did the light interact with it? So now you've got a definition to remind you what does that word mean? And now you also have an example of a material. If you wanted to make the light do it, what would the right material be? How might an optical engineer use our findings?
It can help them make their jobs easier.
yeah, because they'll know what's like reflective, what's not, what's absorbent.
If they're doing like a specific project that they're doing, and maybe they're using materials.
Like your project is to
So that instead of them
Block
doing all
off.
the work, they could just use ours instead.
block off.
So what you see near you on the clipboards are a couple of pages that explain some different types of optical engineering technologies. Here's the laser light that's going down, but it also shows an arrow going up again. What type of interaction is that showing that the light is doing with the DVD surface? That's reflection. Very good. The next one is a microscope, still an optical engineering technology, because it's helping you with the way you see things. And then here's the light source. So it could be a bulb. It might also be a mirror. Do we have any light transmission? Is there any place where the light is going through it? Yes. Where is the light going through a piece of this microscope?
Right next to where it says object under.
Okay, so we've got light transmitting through the object, and I'm asking you to start thinking like an optical engineer. So you're going to pick one of these technologies. You're going to pick microscope, DVD, or fiber optics. You're going to tell me, what does the technology do? Is it transmitting, reflecting, or absorbing light, and where? It says you can check as many as you want. I want to tell you that I'm very proud of the work that you did today. I'm very impressed and looking forward to lesson 3. Lesson 2 I find beneficial because, number one, lesson 1 was so much with the listening and the thinking. They are itching to get their hands on stuff. But also lesson 2 is great because they can I have a lot of students who, like I said, are visual, so they need to kind of sort and classify stuff. And so if they were unclear at all about definitions to the terms that we talked about in the story, they can say, well, I said that these materials are reflective because they all do this. And it helps them to visually ingest that understanding of what those vocabulary words are. Lesson 2 is great for those 2 reasons. Number 1, it gets the kids who are itchy to get their hands on stuff. And number 2, it helps them to kind of absorb the meanings to this new vocabulary. And I've had students come back to me after and say, you know, I looked around my house, and it's not just light bulbs that are optical technology, you know, and so it makes them more worldly aware.